In this demo, we present to you ProcessProfiler3D, a framework for analyzing and comparing the performance of multiple process cohorts. ProcessProfiler enables the interactive splitting of an event log into multiple process cohorts. It then enables the visual comparison of various performance indicators relating to both process activities and process activity pairs. Performance data is also aggregated at multiple levels of process abstraction, so users can drill down into interesting details. So how can such an analysis be of value for an organization? For this demo, we will use the example of the emergency department of a hospital. For example, for a hospital, it can be important to know how long different patients are going to stay in different departments for capacity planning. If the activities within this department are captured in an event log, we can then extract a process model, such as the one you see here, and visualize how each patient is handled in the department. Depending on different contextual factors, each patient will be handled slightly differently, and this information is often stored in the event log as well. However, analyzing this information can be difficult, and here ProcessProfiler can help. But first, let's have a look at the example process used in this demo. The process starts with a patient presenting at the emergency department. Then a triage is performed to assess the urgency of their case. Depending on the urgency of the case, they are then assigned either to a waiting area or moved directly to the emergency OP. Eventually, a doctor will see them to decide whether further diagnostics are needed, the patient can be discharged home, or whether they need to be moved to a specialized care unit. Once a patient has been admitted to one of the specialized care units, they are continuously observed and specialized medical procedures can be performed. A doctor is then regularly consulted to decide whether the patient needs to be kept in the unit, moved to a ward, or can be discharged home. The event log in this demo is simulated based on our experience with real hospital data and contains 150 cases. To ease the analysis of this process, we have also created a hierarchical version of the process model using Volpert. The first step of the analysis is the definition of multiple process cohorts. For this purpose, the event log can be split interactively using any of the trace attributes to select traces. You can see that the event log we are using has 4 literal trace attributes, including the age group of the patient and the severity of the emergency. Let's split the event log first along the age group of the patient, so that we have 3 cohorts. We will define 1 cohort for children, 1 for adult patients, and 1 for senior patients. Once these cohorts are defined, ProcessProfiler will automatically split the event log and calculate performance indicators for each cohort. We can then view this performance data in tabular form or visualize it on top of the process using one of several visualization techniques. Let's start by visualizing performance indicators for individual nodes using a 2-dimensional bar chart. By default, both height and width of each bar indicate the relative frequency of this activity for each cohort. However, many other performance indicators can also be used. Let's assign the average duration for this activity to the height of the bar. Depending on your preferences, you can also use other visualization techniques, such as the triangle chart. Again, the width and height of the triangle can be assigned to different performance indicators. If the floating labels get in the way, you can use the F key to deactivate them. To get a better overview of how cases in each cohort perform, let's have a look at a different performance indicator, the average runtime. This measure indicates how long it takes on average until the activity is executed in a case. We can now see that it takes much longer for cases involving senior patients until the case is closed. Be aware that by default the bar heights are only relative to other bars for the same activity. To change this, we can normalize bar heights across a sub-process or the entire process model. Drilling down into the first sub-process, there don't appear to be any major differences in the initial treatment of patients. However, in the specialized treatment subprocess, we can see that the runtime for senior patients increases towards the end of the process. To figure out the cause of this difference, let's look at some other performance indicators. For example, let's look at the time a patient has to wait before an activity is started. Well, these all look very similar, so the issue is not here. How about the synchronization time between parallel activities? We can immediately see a difference here. So let's have a closer look at waiting times between individual activity pairs. For this purpose, we use the magnetic line visualization technique. For this technique, the height of each arc indicates the value of the performance indicator relative to each other cohort. If two values are the same or very close, their arcs get merged into a striped arc. This technique can be used to identify bottlenecks in waiting time between two activities. Looking at the subprocess again, we can see that there's a long waiting time between the observation activity and the end of the process. However, these waiting times seem to be comparable across all process cohorts, so this is not the difference either. This gives you an overview of how to use ProcessProfiler to analyze differences in node and node pair related performance indicators, as described in our recent Decision Support Systems article. However, to take this analysis even further, we have recently introduced a new visualization technique that we call the trajectory view. To better explain this technique, I will first create a cohort with only one case in it. What you're being shown when you display the trajectory of a cohort is the path of each case through the process model. However, the height of each point in that path indicates the runtime of the case at that point. This way you can not only identify timing differences between different cases, but you can also see control flow differences such as loops at the same time. Going back to our age group cohorts, we can again see that cases with senior patients do take a lot longer than all other cases. However, the view is rather cluttered, so let's see if we can filter out some cases by using a different perspective first. Let's define cohorts based on the emergency severity. We can now see that cases with minor injuries are immediately treated and then discharged home. The cases that we are interested in are therefore in one of the other severity categories. To filter these cases, let's group all non-minor severity cases into one cohort and then split this group into subcohorts based on age group. We can now filter out minor injury cases while still seeing the different age group cohorts. By further filtering on individual cohorts, we can then see that the main difference between age group cohorts is in the specialized treatment loop. As it is still difficult to see what's going on in detail, let's create cohorts with one example case for each age group. This enables us to see that for senior patients, often multiple loops of specialized treatment occur, which explains the longer runtime of cases involving senior patients. So overall, this video has demonstrated how ProcessProfiler can be used to interactively split an event log into process cohorts, as well as how it can be used to analyze performance differences between these process cohorts by visualizing performance indicators at multiple levels of process abstraction, as well as case trajectories, in order to gain deeper insight into the processes of an organization. ProcessProfiler3D has been implemented as a set of plugins for the process mining framework PROM. These plugins are available for download in the ProcessProfiler3D package. In addition, the entire source code can be found on the PROM repository.